So you got to this video because you're interested in programming and you're not really sure how to start. So the good news is there's actually a lot of valid paths that you can take to get there, although which path you take might actually depend a little bit about what sort of thing you're trying to do and what kind of things you're trying to accomplish. Now I do want to make sure to note that the most important thing about learning programming isn't necessarily which language you pick. Any language you pick, you can be successful in. The most important thing is that you actually stick with it. So to me, the most critical criteria is something that's both kind of easy to learn, easy to pick up, easy to get started with, but also interesting enough that you might actually want to make your own projects and get some of your own practice in with this programming language. I'm going to give you my advice based on 11 years of industry experience as a programmer and also somebody who has taught computer science in high school and college for many, many years. For each of these, I will also provide some examples. I'll show you what these languages look like and how you might get started with them. And I'm also going to rate them on basically 5 criteria, which are how easy it is to set it up, how easy it is to learn or use, how many tutorials or how many resources are available for this language on the internet, how useful it is if you want to be a hobbyist, so to make your own projects and things like that, and how useful it is in the industry. So how likely are you to get a job by focusing on this language? So I'm going to cover these for each language, and we're going to start one by one. We'll start with one that might be a little bit controversial, but I have to cover. I want to talk about block-based languages because they're used quite a bit to teach computer science from elementary school to high school, and they're pretty popular languages for this. Now, I recognize most people probably won't be very interested in learning these languages, but if you are, for example, a father who wants to teach their kid how to program from an early age, this is actually a pretty good choice. I would actually start with this to see if this can garner some interest. Now, that aside, let me go through some of the specs of how I feel about these block-based languages. And by the way, block-based languages come in many forms. The most well-known are probably Scratch and Snap. There's also different organizations such as Code.org that have their own versions of block-based languages. Theirs is based off JavaScript. Now, the primary advantage of using block-based languages is that it's extremely easy to get started with them right away. You can just go to a website and you can start using them right away, and they're also really, really easy to learn because all of the blocks are available from the start, and you can kind of see just from a glance what's available. And this is a pretty good way to just get introduced to computer science. You can learn about loops, you can learn about variables, you can learn about conditionals, and it's all available and it's all visible, and it has pretty good documentation. Now the problem is there's not a lot of, in the words of tutorials out there. These are useful especially if you're taking a class, like in high school, but there's not a whole lot of online tutorials about how to actually do cool stuff with this. It's also not very useful in the industry at all, as in it has zero use. It's not used by any company in the industry. And you might find some use as a hobbyist to make some simple games or something. But now your question might be, are these actually even real programming languages? And the answer is absolutely yes. These are programming languages. They're very, very high-level programming languages, which means a lot of the details are hidden from you or abstracted. However, some of these are directly based off lower-level languages that I will also recommend, such as JavaScript. You can access Snap through snap.berkeley.edu. You can click Run Snap to create a new project here. As you can see, we can do some pretty basic things here, but you might notice that pretty much all of the blocks are predefined, and you can just basically drag them in, like just drag and drop. Here we're going to make just a real simple little program. It's just going to move and turn 90 degrees, and it's going to wait half a second, and it's going to do that 4 times. This kind of draws a square. You can also use a pen to put a pen down, and we'll make the pen blue, and that is going to draw a blue square. So nice and simple, pretty straightforward, but as you can see, you can do a lot of different programming stuff here. Here, instead of making it repeat 4 times, we'll put it inside a loop that just repeats 4 times. It'll do the exact same thing. Pretty straightforward. Now what makes Snap pretty interesting is that you can actually do a lot with graphics with it. So you can pretty quickly have like a little character here and have like some custom behaviors, such as making it so whenever you click on that character, it's going to make him move a couple steps and maybe even draw something. You can actually do this to make a pretty straightforward game. Now Code.org provides a thing called AppLab, which allows you to use a different kind of programming language, which is actually based directly off JavaScript. This one's actually tied in with this design mode here, so you can like drag in buttons and stuff. You might notice this thing on the left is shaped like a phone, because you can actually use this in your phone. You can import it to your phone. And we can add some basic events, like over here. I'm going to make this block say that when button 1 is clicked, I'm going to set the text on label 1 to Hello World.
And then you see that when I run this program and I click on the button, the text on the label is going to change to Hello World. Nice and simple little phone app. One really cool thing about App Lab and Code.org in general is if you click Show Text over here, it's actually going to turn your blocks back into text. This is actually just JavaScript. You can write some JavaScript code here like var a equals 1, var b equals 2, and then I'm going to make it so that the set text, instead of setting it to just Hello World, we're going to set it to the sum of a plus b. And we're going to turn this text back into blocks, as you can see. Works really smoothly. And when we click on the button, it sets the value to 3, which is that sum.
Alright, now we're getting into languages that are actually used beyond just education. I would say Python is actually, in my opinion, probably the best language to start learning how to program with. And it's not just because it's very popular with education. In fact, it's not just a language that's useful for beginners. That's kind of a misconception that a lot of people get, is that Python is just kind of an entry-level language, and then you learn Python and you move on to more advanced languages. That's actually not the case. I would even go as far as to say that Python is one of the most prolific multi-use languages, and I would even go as far as to say that it's used in most companies. All companies that I've ever been part of have used Python in some way or another. Alright, so let's check out how Python stacks up. So from what you can see here, what really sets Python apart, what makes Python what it is how simple it is to really get started with it, how simple it is to just build something right away and to just start learning the language right away. Normally, when you learn a new language, the first thing you're going to do is you're going to do the hello world, which is you're going to try to print the words hello world to the screen. And once you do that, you've basically set up your environment. Now in Python, hello world is literally print hello world. It doesn't get any easier than that. Python is also well known for being an easy language to read. It's pretty self-explanatory when you're reading Python code what it's doing. Although one caveat that some people complain about is that unlike other languages where you use curly braces to set the bounds of your different blocks of code, in Python you use tabs. And that's a big point of contention for some people. But for most beginners, that's not really a big hurdle. In terms of tutorials, Python is probably the language with the most tutorials because it's such a popular language to start with. So there's tutorials all over the place, and not just for how to learn the language and how to program in Python. You can find tutorials from the vantage of schools, education in college, and even more advanced stuff. And often you will see a lot of videos about it. So where it might fall a little shorter from some of my other recommendations is if you're just a hobbyist getting started, you can actually build some really cool stuff with Python, but it might take you a little longer to get there. So to start out, you're probably going to be building a really simple type of console thing like a calculator app or something like that. But eventually you can actually do some pretty cool stuff. What makes Python really awesome, as well as everything else I've mentioned here, is that you can import a very, very large number of libraries. There's a lot of libraries and frameworks that are built for Python that let you do tons of stuff. So once you get a little better at it, one of the first things you might do is you might set up the framework Pygame, which will let you make some pretty simple games in Python. It's something that's actually fairly beginner friendly, I would say. Now what might surprise some people is how prevalent Python is in the industry and how useful it is to know just for getting a job. A lot of people get a job just knowing Python. I've met many of these people actually. It's actually a very versatile language. Some of the stuff you might do with Python, you might use it to write scripts for various small tasks like build tasks and things like that. You might use it to program server backends. It's not the best language for a server backend, but there's many servers that are simple enough where it might make sense to use. One very popular use for Python is data science. It's an up-and-coming field, and a lot of data scientists use Python, which has tons of libraries to very effectively work with data. And another big up-and-coming field where Python has made a showing has been in machine learning. Machine learning models use Python to do a variety of things. It's an area I'm less familiar with, but I know that a lot of my peers have used this for that purpose. And in general, Python is a great just generalist language. It's just very versatile, so you can do a variety of things with it. I've heard people consider Python to be a kind of a support language, but in my opinion, it's a little more than that. And even if it's just a support language, it's probably among the best support languages you can have. So what I'm going to do is I'm going to show some examples of how you can set up Python. There's a couple different ways to do that. We'll start with the easiest. The easiest way to start running Python right away is actually just to find a free online Python interpreter. You just go on Google and you type Python online interpreter. You're going to find a lot of options, although just be warned, a lot of them will have ads. So let's just scroll down a little bit here. How about this one right here? So let's go ahead and open this up. Now sure, there's a lot going on here, but we already saw hello world earlier, and by pressing run here, it'll run your hello world, and here you will see it in the console. Let's type up just a real quick, simple program. I'm going to type some stuff here. As you see, this is just a very, very simple program. I just made a little loop, and I printed out the results of each item in the loop. Now, I want to emphasize, in this video, my focus isn't really to teach you how to program. I might save that for another video. I'm just showing you how to get started with these languages. Once you're ready to get a little more serious with Python, you might actually want to choose to go to a more professional website like Replit. You'll have to create an account here. It is free, although a lot of things are behind a paywall. But there's a lot of stuff that are available here. So for example, there's all of these really helpful tutorials that are built into Replit, and they actually use their own framework, their own system. So you might see here, for example, 100 Days of Code, Complete Python Course. When you're ready to actually write code, the advantage of Replit is it more closely resembles an actual coding environment that you might see in a professional project. So let's say we want to go here to code and create our first REPL. You might pick Python, and then we're going to create it. It's going to take a little while to set it up, but it's actually creating a little server for you, and you can have a lot of stuff here. So for example, you can set up several different files, and if you're not really sure what to do, it can even give you some examples of how to start out. So I'm going to start with an example, and I'll do an input one here, and it also starts you with some starter code here. So we can run it, and I can actually already see my project here in the console on the right. So I'm going to put my name, and it's going to do what the code said, which is checks my name, put in my name, and it says hi name. So that's a great example of seeing how you might actually structure, let's say, a real project. Now notably, there is a lot of other stuff here. If you look at the tools, it might make your head hurt just looking at all the different things that are available here. And even as a beginner, you might not really know what to do with all these different files. That's why it's pretty helpful when you have something like this to really start with a tutorial or something that can guide you along. Nonetheless, this is a pretty good starter approach using something like Replit. Let's talk about JavaScript. JavaScript is by far my #1 recommendation for pretty much new programmers, but also veterans alike. On its own, it's not that interesting, but when you pair it with CSS, HTML, or a framework like Node.js or React, you get a really, really powerful language, especially when you tack on TypeScript to the top of it. I'll talk about that later. JavaScript is an extremely versatile language. It's the language for front-end web development, and with Node.js, you can also use JavaScript to make a server, which is great. It means you can make it full stack. You can make the entire front end and server technology using just JavaScript. I've also used it quite a bit just as a standard scripting language, just to perform little tasks here and there. It's great for that because it's actually really easy to read and write JavaScript code for small tasks. And if for whatever reason you really want to make a desktop app, you can always use Electron, which is powered with JavaScript. And you can make a desktop app, though that is, I would say, a fair bit more advanced than most of the stuff that we're talking about here. So let's see how this one stacks up. Overall, JavaScript, what really sets it apart is that it runs right off your browser. So you already have something, just by, if you're watching this on YouTube, you already have something that can run JavaScript right away. Being able to set up an environment to work with JavaScript is very straightforward as well. I'll show a couple examples of that. Overall, the structure and just way of writing JavaScript is pretty straightforward. It's actually quite a bit like Python in that there's not a whole lot of complexity to the code that you write in JavaScript. It kind of reads the way it runs. That makes it pretty accessible for beginners, although as you start getting more advanced, you start running into some issues, which, as I will describe later, are generally resolved by having TypeScript. In terms of tutorials, there's a lot of tutorials, of course, but what I've found is that they tend to be a little bit more advanced, or just kind of, they tend to have a bigger variety of difficulties than what you would find with something like Python, because JavaScript is not generally seen as a good beginner language in the same way Python is by a lot of circles. So a lot of the tutorials are dedicated more to advanced stuff or to web development, etc. Many of the tutorials you'll find are specific about things like frameworks like React or Node.js, but you'll find a wealth of resources out there. JavaScript is a very popular language. Now for a hobbyist, JavaScript is great because you can make a website with it, and that alone can give you a great project to work on over time. It's something that's tangible, something you can create from start to finish, which is a very, very good way to learn a language. If you want to go even further with it, you can go full stack by making a little server, and then you have a full website. You have a front end, you have a back end, you have a whole thing going. And that lets you do some pretty cool stuff as a hobby. Now, where JavaScript is off the charts is in how useful it is in the industry. If you learn JavaScript, you've learned a really, really good language to use in the industry. because JavaScript is, no matter how you see it, probably going to, for a very long time, be one of the most popular languages for the job industry. And the reason for that is because it's pretty much the language of front-end web development. And it's become popular for other things as well. The data for this kind of varies, and I haven't found a single cohesive piece on it, but most of what I've read seems to suggest that the top preferred language in terms of what people are looking for in the industry is JavaScript. Every company nowadays is pretty much going to be dabbling in websites in some way or another, and knowing JavaScript for that is pretty essential. So let's make a note about TypeScript. So what is TypeScript? TypeScript is something that you basically stack on top of JavaScript. TypeScript will compile down to JavaScript, which means when you write something in TypeScript, eventually it just becomes something in JavaScript. But by being able to write it in TypeScript, you have a lot of advantages. The main one is that a TypeScript project is basically JavaScript with guardrails, which means it stops you from doing things that normally would really mess you up. It stops you from shooting yourself in the foot, essentially. A lot of people, when they first get started with TypeScript, they don't really see the point. They're like, why are you making things harder on yourself? But it turns out that when your projects get bigger and more complex, you need that complexity that TypeScript provides in order to stop yourself from making mistakes. And that's why TypeScript is so beloved in the industry. All that said, I don't know if I'd recommend TypeScript as a starter for new people, but as you get more comfortable with JavaScript, eventually you're going to start dabble a little bit in TypeScript. So with all that out of the way, let's look at some examples of JavaScript and how we can get started with it in a couple different contexts. The easiest way to get started with some JavaScript and just to play around with it a little bit is probably to go to jsfiddle.net. jsfiddle.net gives you a HTML file, a CSS file, and a JavaScript file you can play around with. And on the bottom right, you can see the results of what you're doing. Let's try a basic Hello World program. I'm going to type some stuff here. Here's a basic Hello World. I'm logging Hello World to the console. And let's try to run it. Now, you notice I ran it, but nothing happened. Unless you go down here and you click on this little thing, and you find that what happened here is I output Hello World into the console. Console is used for debugging. The user won't actually see this unless they check the console themselves. It's not usually visible to them. So let's add something visual to our little test website here. That's where the HTML comes in. So I'm going to type some stuff here. So here I typed Hello World in between these two divs, which are HTML elements. Let's see what happens when I run this. This here shows you that it's displaying Hello World into our little program. Now let's mess around the CSS a little bit. CSS is cascading style sheets, which determines the styling for your program. I'm going to type some stuff here. Now when I run this program, let's see what happens. Notice now that the text is blue. So as you see, HTML determined what's in the program, basically the layout. CSS determined the style, and so far I haven't seen much from JavaScript. So let's make it do something a little more interesting. So I made it so that it's going to find this element, which I've tagged with a specific ID, and it's going to change the inner text from whatever it was to new text. So let's see what happens when I run this. Notice that it replaced the inner text that was there before, Hello World, with new text. Just to show one more little thing, I can show here that if I go inside the HTML, I can actually embed a script directly into the HTML. I'm going to do another console log here, and I'm going to type some other thing. And let's see what this does. As you see, it's going to log it to the console, just like it did before. But notice that I was able to write this script as part of the HTML instead of in the separate JavaScript file. This kind of shows you the versatility of how HTML, CSS, and JavaScript work together. In a normal project, you would include the JavaScript as a separate file and reference it in the HTML by linking to it from one of these tags. Now, by default, any browser is already a JavaScript interpreter. One thing you might have tried before, if you right-click on any website, for example, if you're in Google, you can actually check the page source. And this actually shows you all of the JavaScript and HTML and CSS for this page. But even more interesting, let's try this. Right-click and do inspect. This will open up this whole bunch of stuff right here. These are called the browser dev tools. They're for developers to be able to do stuff. But if you go to the console right here, you can actually type into the console and check this out. I'm going to type some stuff. I define two variables, a and b, and then I'm going to type this, a plus b. Notice that a was 1 and b was 2. When I typed a plus b, it actually added them together to equal 3. This shows you that you can actually just type JavaScript in your browser, just standard, and it'll already work. JavaScript can even just by default open up any HTML file that you create, and it'll open it up as a website. So let's check this one out here. I have index.html here. Let's see what's inside. I'm going to open it with Notepad. This is an HTML file, and here we see something I showed earlier. We have a div that would say hello world, and then I'm running a little script in it. So this script is going to set up a variable A, a variable B. It's going to add them together. It's going to log that, and then finally it's going to set my text, this element up here, to the sum is C, and it's going to show what the sum is of A and B. So let's check that out. I'm going to close this file, and then I'm going to right click on it, and I'm going to do open with Google Chrome. And Google Chrome knows to open this as an HTML file because it has the HTML extension. And here you see that we have set the text, so it says the sum is 3. This is a good little example of how you can set up HTML, CSS, and JavaScript with just an HTML file in your browser. Eventually you might want to run JavaScript on its own, such as if you want to run a JavaScript server. For that, you're going to want to use Node.js. So let's check out Node.js real quick. You click here on nodejs.org, and you can download the installer for Node.js. You're going to want to install that. I already have it installed, so I'm going to skip that, but you just download it and install it. And now let's see how you might use that. So once it's installed, I'm going to run it from the command prompt. I have a file here called file.js. I'm going to take a quick peek inside, see what there is. I can open it in Notepad, and it's got a whole bunch of stuff here. We're not going to worry too much about what this means, but basically it's going to ask you for your name, and then we're going to run this program so the user can type in their name, and it's going to say hello to them. So to run this file, file.js, I'm going to go to that folder, and I'm just going to type node file.js. And that's going to run the file through Node.js. Let's take a look. It's going to say, what's your name? I say Flavio. And it says, hi Flavio. So this shows you how you can use Node.js to run a file. Notice what's actually going to be used to write servers in JavaScript, but it's a little different. It's not just a one-time thing that you run. Instead, it'll be a server that's going to be listening to commands or to requests, and it's going to respond to them. Finally, let's talk about C#. I would really recommend C# as a good beginner language, and that might be surprising to some people because C# is not exactly the most beginner-friendly language, but it has some pretty good advantages over some of the ones I already described. C# is especially good if you want to learn a language that's compiled as opposed to the interpreted languages we looked at earlier, and strong type, which is a property that a lot of really popular and useful languages also have. Compared to languages like C and C++, which are also compiled and strong typed, C# is a lot easier to learn. And if you learn C#, you've basically already learned Java. Some people call it Microsoft Java, kind of as an inside joke, because Java and C# are extremely similar in many, many ways. So let's see how C# stacks up. Compared to the other languages that I introduced, it takes a little longer to get set up with C#. In fact, it might take quite a bit longer. If you want to use just C# on its own, you're going to need to set up Visual Studio or some other IDE. You're going to have to download a whole bunch of stuff to make it work. It's a little bit more of a hassle. Although I suspect most people who want to learn C# are going to do it because they want to learn how to use Unity, which I'll talk a little bit more about later. If you want to use it for Unity, all you have to do is install Unity. But let me just be clear that C# used in Unity is a little bit different than C# used just on its own. Though let me be clear that the reason I am recommending C# as a good starter is specifically because of the existence of engines like Unity and the Godot engine, which use C#. Though because of its compiled and strong type nature, some beginners might find that C# is a little bit different to learn than some of the other languages like Python, and it might be a little trickier in some ways. So you might need a little bit of guidance. And with that in mind, tutorials for C# are quite plentiful because specifically of Unity. There's a lot of Unity tutorials out there, and that's a good way to start, but it might not give you the full understanding of the language. If you want to learn C# by itself, it can actually be kind of tricky to find a good tutorial. A lot of the tutorials available about C# are made because of Unity, and going a little bit deeper into just the language, you might find the tutorials to be quite advanced. Now, all that said, once again, the reason I'm suggesting C# is because of the hobbyist potential of it. It's quite out of the charts, and that's because a lot of people want to learn how to program to make games. And if you are one of these people, my #1 recommendation is to learn C# and Unity. It's maybe a little bit harder than some of the other frameworks, like I mentioned Pygame earlier for Python. I actually do believe that setting up C# with Unity is a lot easier than learning how to do the same thing in a framework like Pygame, even though Python is an easier language overall. There's also a lot more resources available for Unity. In terms of job security for C#, C# is a language with a lot of job security. And the reason for that is because there's a lot of companies, often called .NET houses, which are companies that exclusively have software that is based off .NET, which is a framework of C#. Those companies will, and probably for the foreseeable future, stick with C#. And that means that C# kind of has a unique nature in the industry, where there are companies that basically want you to know how to use this language because they want to continue supporting this software. I don't know how much longer that's going to go on, but I honestly got to say that C# is a pretty versatile language outside of these video game frameworks. And it was my first job was in C#, and many jobs out there still use it. It's a good server language, so servers written in C# are actually pretty prevalent. It used to be a pretty popular language for desktop apps, but desktop apps are a little bit less popular than they used to be. But nonetheless, it's very versatile. I recommend it, I'd say, for the industry. So with that, let's talk about a couple examples of how you might get started with C#. No surprise, but the main one is probably going to be Unity. To use C# outside of Unity, you're going to want to install an IDE. IDE is an integrated development environment. It helps you build and do a whole bunch of stuff with that language. So the best IDE to use for C# is Visual Studio. And Visual Studio is normally very expensive, but the community version is actually free, as it says here, for students, open source contributors, and individuals, which would be yourself. So you can install it from here. Now note that as the years change, the way that you install Visual Studio is going to change quite a bit, so this is going to be outdated pretty quickly. But for now, you install it from here. And the thing to point out is there's quite a lot of different things you can install through Visual Studio. You might notice here that there's actually Python development that's available, ASP.NET, Azure, Node.js, there's a bunch of stuff. So if you're going to use this for C#, you're going to want to make sure that you're reading from a tutorial that's going to guide you through it. What I'm going to install is just .NET Desktop Development, because as it says here, I'm going to do a console application using C#. That's what I'm going to do. Now this is going to take a good long time to install and download, and I'm going to be back here once it's done. Now once you've finished installing Visual Studio, let's go ahead and open it. Now I want to reiterate, if you're not coming in here with a tutorial that's telling you how to do things step by step, you're going to be a little bit lost here, but my intention here is just to kind of show you some of the possibilities. So we're going to start by creating a new project, and here is where you get to pick a template. So I'm going to pick a C# console app. So this is a non-visual app. It's just going to print something out to the console. I'm going to hit next. I'm just going to call it console app 1, and just going to hit OK. Let's go ahead and create it. So the nice thing about an IDE is actually that it sets you up with a starting working app. It might not look like much, but it's already got a whole bunch of stuff. If you look at this, it's kind of hard to figure out what this is actually saying, but I'll show you. Now the nice thing is you can actually start running this C# program right away just by hitting start over here. So I'm going to do that. Now you saw that something popped up real quick and then just went away. So that's your starting app. It doesn't do anything, but we're going to make it do something. So I'm going to go ahead and type up a real quick, simple hello world program, and I'm going to type this inside the main. All right, so let's go ahead and write some stuff. Okay, and now that I have written the program with a typo that I'm going to fix here, I'm going to go ahead and run it, and it's going to ask me in the console, what is your name? I'm going to put my name, and it's going to say hello and then my name, and it's going to wait for a key before it closes the program. And just like that, I wrote a real simple C# program. One thing that you might notice is that by having an IDE, you get a lot of cool stuff. Like if you hover over different parts of the code, it'll tell you what they do. And you might have noticed as I was typing this that it gave me little hints. Like if I am trying to type right line, it'll give me hints about what to do. This is called IntelliSense, and it's a very, very helpful aspect of an IDE. All right, let's do one last example here. So in this example, I have installed Unity and I have opened a new 2D project. This project is pretty much empty. What I'm going to show is just a real simple way in which you would create a C# script in Unity. So to start out, I'm going to have this empty scene. I'm going to create a new object. Let's go ahead and create let's say a circle. So here now we have a circle, right? And I can move the circle around. What I'm going to do is I'm going to add a component to it. So in Unity, C# scripts are added as things called components. So I'm going to make a component. I'm going to call it just move. So I'm going to create and add a new script called move. All right. So that creates this C# file here. You can see that my C# script is right over here. You can actually see the code over here, but we're not going to edit the code from here. Instead, we're going to edit it from Visual Studio 2019, which we installed earlier. So I'm going to double click on it. Now I have it already set up to open in Visual Studio 2019. If you're doing this for the first time, you might have to do a little bit of setup to get this to work. And you can see that I have an editor that has a little bit of code. This is an empty boilerplate code for the component that I added. And it says you can put code here in start or here in update. So I'm going to put some real simple code that's going to make the circle move left when I press left and make the circle move right when I press right. So here we go. I'm going to type up just a little bit of code. Okay, so back to normal here. I wrote up a little bit of code here. It's not the cleanest code in the world, but basically what it's going to do is it's going to get the circle's position, and if you are pressing the left arrow key, it's going to change the x coordinate of the position by this tiny little amount. It's going to subtract it, and if you press the right arrow, it's going to instead change it positively by this tiny amount, 0.02f. And then finally, at the very end, once it's done changing the position, it's going to set this object's position to whatever the new position is. So let's try that out. I'm going to save this and I'm going to minimize this. So we're back to our script here. It's going to compile the code. And now let's try running the script and seeing what happens. So I'm going to hit play. And now I have my running game right here. And as I press the right arrow, it's going to move right. And as I press the left arrow, it's going to move left. So we have basic movement for this little circle in our little 2D game. It's just a little appetizer sampler, so to speak, of how C# scripting would look like in Unity. I need to mention here there's a pretty big difference between how you would script something in C# in Unity versus how you would make a, let's say, a normal program in C#. And the reason that's different is because the way that Unity is set up is through the component model, in which every object has components that are programmed in C#, and all of your C# scripts are run through those components that run in different cycles throughout the application's lifetime process. So with that, I think that's the last example I need to show here for Unity. There's a lot of Unity tutorials. I might make some myself. We'll see. But this is just meant to show you some examples. So in conclusion, which language should you pick? Honestly, the answer is it doesn't really matter. Pick something that you want to do, pick a goal, and pick the language that's appropriate for that. I would say if you want to make a website, choose JavaScript. If you want to make a game, choose C# with Unity. If you want a language that's pretty straightforward to read and start with, choose Python. Or you might want to go with something else entirely that's not mentioned in this video. The key is that you stick with it and you find something that you can practice with and learn some basic programming skills. You want to learn some basic syntax, you want to learn loops, you want to learn conditionals, and whatever you learn in your first language is going to transfer very easily into your next language. My first language was Ruby because that's a language that was available for scripting in RPG Maker way back in the day. From Ruby, I never really used it in any capacity, but it helped me learn other languages. Don't let people pressure you into thinking that the only way to program is to learn a language like C++ just because some of the other languages won't teach you about memory or things like that. You'll get there eventually. The important thing is that you pick a language that you can actually get started with and get some practice with. Everything else will come naturally. So with that, I hope this was a good guide to help you pick a language to start programming with, and great luck with your programming journey.